Welcome to Certified Professional in Healthcare Information and Management System CPHIMS Exam preparation video. In first video, I have covered the healthcare environment. In this video, I will cover the technology environment. Okay. Based on CPHIMS examination detailed content outline, CPHIMS aspirants are required to study following topics under this section. Articulate characteristic of applications commonly used in healthcare environment, for example, clinical, administrative, financial, consumer, and business intelligence. Articulate characteristic of technologies infrastructure that support the healthcare environment, for example, network, communications, hardware, mobile and medical devices, and trend and challenges in healthcare technologies. Let's explore first topic, articulate characteristic of application commonly used in healthcare. For example, clinical, administrative, financial, consumer, business intelligence. Okay. Here is the list of applications commonly used in healthcare: clinical applications, administrative applications, financial applications, and consumer applications. Let's explore each applications little deeper. Clinical applications is a computer-based system that is designed for collecting, storing, manipulating, and making available clinical information important to healthcare delivery process. Clinical applications support patient care where it's being delivered. Some examples of clinical applications are electronic health record, picture archiving and communication system, also known as PACS system, departmental system, care setting niche system, and knowledge-based system. Let's see electronic health record. An electronic health record is a digital version of patient paper chart. EHR are real-time, patient-centered record that make information available instantly and securely to authorized users. While an EHR does contain the medical and treatment history of patient, an EHR system is built to go beyond standard clinical data collection in provider's office and can be inclusive of a broader view of patient's care. Okay. EHR can contain patient's medical history, diagnosis, medication, treatment plan, immunization date, allergies, radiology images, and laboratory and test results. EHR can allow access to evidence-based tools that providers can use to make decisions about patient's care and automate and streamline provider workflow. One of the key features of EHR is that health information can be created, managed by authorized provider in digital format, capable of being shared with other providers across more than one healthcare organization. EHR are built to share information with other healthcare providers and organizations such as laboratories, specialists, medical imaging facilities, pharmacies, emergency facilities, school and workplace clinics. So they contain information from all clinicians involved in patient care. Okay. This picture shows how patient medical data is accessed by hospital practitioners using EHR system. Remember, patient cannot change or modify his or her electronic health record data. Now we'll explore PACS system. PACS system, picture archiving and communication system. The PACS store and display images from ultrasound to computed tomography, CT scan, and MRIs. Okay. Digital imaging and communication in medicine, DICOM is used as a standard for images. Now we'll see the next applications, departmental systems. Okay. Following system can be defined as departmental system, laboratory information system, radiology information system, and pharmacy information system. Let's see laboratory. Logical observation identify names and codes. LOINC is database and universal standard for identifying medical laboratories observation. Okay. Under pharmacy, National Council for Prescription Drug Program (NCPDP) provide standards for prescription drugs pharmacy informations. Now we will see the next applications, that is Care setting niche systems. Care setting niche system can be defined as emergency department system, operating room system, oncology, and labor and delivery. Now we'll see the next system, knowledge-based system. Okay, a knowledge-based system uses a knowledge base containing accumulated experience and set of rules for applying the knowledge to a particular situation. CDS, Clinical Decision Support System, which uses a knowledge base, applies rules to patient data using an inference engine and display the result to the end users. Okay. Now we'll see the next healthcare application, administrative applications. Is responsible for information technology that support core hospital business functions such as human resources, payroll, accounting, public safety, admission, financial, and registration. Okay. Following applications comes under administrative applications: business intelligence, scheduling, bed management, and practice management system. Business intelligence. Okay. Business intelligence is a technology-driven process for analyzing data and presenting actionable information to help executive, manager, and other corporate end users make informed business decisions. Business intelligence in healthcare. Okay. With constantly increasing number of data sources, the complexity of data generated within healthcare organization, the need for advanced analytics to support decision-making capabilities is growing, and hospital and other healthcare organizations require predictive modeling and data visualization tool from modern business intelligence software application to gain insight regarding patient care and satisfaction, labor distribution, clinical operation, daily practice of physicians and nurses, and administration and management. Okay. Let's try to understand business intelligence through this image. As we know, a picture is worth thousands of words. Okay. This part of image shows how data is extracted from various data sources: finance, EMR, lab, pharmacy, etc., and send data to warehouse using ETL tools. ETL tools stand for extract, transform, and load. This extract, transform, and load. This is called ETL tools. The typical real-life ETL cycle consists of following execution steps: cycle initiation, build reference data, extract from source, validate, transform. Transform, okay, mean clean, apply business rule, check for data integrity, create aggregates or disaggregate, stage, load into staging table if used, audit report, for example, on compliance with business rule. Also, in case of failure, help to diagnose and repair, publish to target table, and archive. Okay. And this part of image shows data customization. Customization is defined as changing the pre-configured behavior to enable you to analyze new information in your business intelligence dashboard. Okay, and this part of the image shows business intelligence tools, also known as dashboard, shows how easy it can be to report the number of occupied beds, understand the bigger picture of healthcare delivery to make better decision, view and compare the number of admissions, cost diagnosis by department, division, KPI, and more, all in one place. Okay, like scheduling system is scheduling system. System is designed to schedule staff, doctors, residents, tech, nurses, and other team members. Okay, scheduling. Now we'll see the bed management. Okay, system automate bed status with patient locations. And now we will see the next application under administrative application is practice management system. Is designed to streamline the day-to-day task of operating medical facilities. Now we'll see the next application, financial application. Financial applications are computer systems that manage the business aspect of hospitals. Okay. Some of the features of financial information systems are payroll, patient accounting billing, account payable, account receivable, general ledger, fixed assets management, claim management, and contract management. Okay. Let's see payroll. Payroll handle all the recurring and non-recurring payment and deduction for employees. All recurring transactions can be automatically generated each payroll period, with non-recurring transactions such as overtime added to payroll upon approval. It's also possible to maintain employee pay rates, entitlement, full salary movement, and payroll histories. Now let's see the next. Patient accounting and billing. This concentrates on financial transactions generated during a patient visit to the hospital. This includes inpatient, outpatient charges, doctor fees generated across the hospital, the cost of procedure, operation, and medication. The patient accounting systems are commonly referred as a practice management system. Okay. Now we'll see the next. Account payable. Handle the processing of invoice and payment within hospital. Account receivable. This provides support for and the maintenance of record of all clients' invoice and payments. Now let's see the general ledger. This handles the collection and processing and reporting of financial data generated by all the transactions, enabling a current, accurate, and instant view of financial status of the hospital at any point in time. Let's see the fixed asset management. This deal with the asset data retention and depreciation, forecasting the transfer of fixed assets between locations, cost center or department, reclassification of assets and reassessment of asset values, and can function that can be done by the financial information system. Okay. Claim management. Manage all claims that are made to insurance companies. And contract management. Keep track of all ongoing contracts. Let's try to understand how all these systems work together under an integrated healthcare delivery process. Okay, there is a patient journey and integrated administrative process. Under patient journey, patient data is captured. Examination is done. Diagnosis is done. Diagnosis is done. Treatment plan is prepared. Billing and discharge is done. This is the patient journey. Okay. Under integrated administrative process, this part, resource scheduling, stock control, financial record are captured and used during and after patient treatment. Now let's explore next topic, consumer applications. Okay. Consumer health IT application allow patients to manage, share, and control their health information electronically and to assume more active role in management of their health. Electronic personal health record (PHRs) are defined as an electronic record of health-related information on an individual that conforms to nationally recognized interoperability standard and that can be drawn from multiple resources while being managed, shared, and controlled by individual. Okay. An electronic personal health record can exist as a standalone application that allows information to be exported or imported from other resources or applications. Okay. This image shows how PHR system can be used by an individual to record and manage their health related information in private, secure, and confidential, and can be shared to healthcare providers. Okay. Health Vault from Microsoft is a standalone PHR system. Okay. Let's see the next. Tethered PHR, Tethered Personal Health Record System, also referred as a patient portal, typically allow patient to view but not modify data from provider's electronic health record, EHR, electronic health record. Okay. This image shows how patient portal can be interfaced with multiple electronic health record EHRs and allow for a complete bidirectional integration of these messages with EHR system, which allows the portal to display real-time appointment data, laboratory values, and patient demographic information directly from your electronic health record. Okay. Let's see how it's work. Let's try to understand PHSR system through this image. Okay. Collaborative patient devices, like for example wearable devices, mobile devices, and sensor, IoT, Internet of Things, send data to PHSR system. Okay. This send data to PHSR system. Patient is the owner of this data, and he or she can authorize third parties, healthcare providers, laboratories, insurance, and government to view and update PHR data. Okay. Okay. This is an example of wearable devices, how it's work. Okay. Wearable technologies has revolutionized the healthcare industry. The data stored in these wearable devices provide great insight to health condition. Remember ISO IEEE 11073, also known as ADAT-K.A X73 standard apply to wearable wireless point of care system. Okay. Now we'll try the next topic. Now let's explore articulate characteristics of technologies infrastructure that support the healthcare environment, for example network, communication, hardware, mobile, and medical devices. Okay. There are three components of the technology environment. Okay. Okay. Three components of technology environment are hardware, applications, and network. Let's explore hardware. Okay. Technology infrastructure. The term infrastructure is an information technology IT context refer to enterprise entire collection of hardware, software, network, data center, facilities, related equipment used to develop and test, operate, monitor, manage, and or support information technology services. Okay. Let's see healthcare IT infrastructure component. Okay. Healthcare IT infrastructure component are servers, data storage, mobile devices, and medical devices. Let's explore servers. Okay. Servers. In computing, a server is computer program or device that provide functionality for other program or devices called client. This architecture is called the client-server model, and single overall computation is distributed across multiple processes or devices. Servers can provide various functionalities, often called services, such as sharing data or resources among multiple clients or performing computing for a client. A single server can serve multiple clients, and a single client can use multiple servers. A client process may run on same device or may connect over a network to server on different devices. Typical server are database server, file server, mail server, print server, web server, game server, and applications servers. Okay. This picture shows how client server connected through network switch. This is network switch, this is server, and its client connect to server and get data. Okay. Okay. Server can be physical server and virtual server. This is physical server, this is virtual server. Let us try to understand what is the difference. Physical server, each server has its own hardware, memory, network, processing and storage resources. On this hardware, the server operating system is loaded from the OS and you can then run the applications. With virtual machines, you have the same physical server with all the resources, but instead of server operating system, there is a hypervisor such as vSphere or Hyper-V loaded on it. Okay, here. The hypervisor is where you actually create your virtual machine. As you can see on the diagram, each VM has its own virtual devices. These virtual devices, these are our virtual devices. Okay. Virtual CPU, virtual memory, virtual network, interface card and its own virtual disk. On top of this virtual hardware, you load a guest operating system and then your traditional server applications. Let's go back. Alternative option for those organizations that may not have appropriate space or resources to house and maintain their data in-house is cloud computing. It's an information technology at a IT paradigm that enables ubiquitous access to shared pool of configurable system resources and high level of services that can be rapidly provisioned within minimal management effort, often over the internet. Cloud computing relies on sharing of resources to achieve coherence and economies of scale similar to public utility. Okay. Example of cloud computing. Okay, let's try to understand cloud computing terms, okay, associated with cloud computing. So there is enterprise IT, legacy IT, means everything is managed by customer. We can see everything is managed by customer. Application security, database, operating system, virtualization, server storage and networking, data center, everything is managed by customer. Then there is a next type of cloud computing. This is called infrastructure as a service. Under this, infrastructure is managed by provider. Like this part is managed by provider, virtualization, server, storage, networking and data center, and this part is managed by customer, like application, security, database and operating system. Next type is platform as a service. Under this, okay, all this part from security to data center, like security, database, operating system, virtualization, server, storage, networking, data center, all this is managed by, okay, provider, and customer is only responsible for managing applications. And there is a term known as software as a service, means everything is managed by the provider. Okay. Let's explore next hardware component, data storage. Okay, data storage is a general term for archiving data in electromagnetic or other forms for use by computer or devices. Different types of data storage play a different role in computing environment. Okay, can be classified as, okay, magnetic tape storage, optical disk storage, hard drive storage, solid state drive and cloud storage. Let's explore each. Let's see each. Okay, this is an image of magnetic. Okay, this image display optical disk storage. This image shows the internal structure of hard drive. The platters are paired with magnetic heads, usually arranged on a moving actuator arms, which read and write data to platter's surface. This is called a spindle. This is actuator arms which move. This is platters. Okay. On platters, data is stored and retrieved using read write head. Okay, this is called head, read write head, and data is written and erased from platter using this device. Okay. Okay. Now let's see solid state drive. Okay. Solid state drive or solid state disk is solid state storage device that uses integrated circuit assemblies as a memory to store data persistently. Okay. Now let's explore cloud storage. Okay. Cloud storage. Cloud storage is a model of data storage in which digital data is stored in logical pools. The physical storage spans multiple servers, and the physical environment is typically owned and managed by hosting companies. Okay, this diagram shows how cloud storages work. Okay. Okay. Example of cloud storage. These are example of cloud storage. Google. Okay. Google Drive, SkyDrive, Dropbox, and iCloud. Okay. Now let's explore next component, mobile devices. Mobile devices have made a dramatic impact in lowering the barrier to healthcare IT access, as well as giving patients new tools for taking responsibility for personal health. Because mobile device can pair with EHR software, revenue cycle management platform, and other tools, physicians can complete day-to-day tasks with great ease and flexibility. Okay. Some example of mobile device are medical card, handheld device, tablet, smartphone, and BYOD, bring your own device. This image shows medical card. This image is an example of handheld device used in healthcare. This is tablet, how it's being used in healthcare. A smartphone. Now we'll see the bring your own device. Okay, the consumerization of IT and the bring your own device (BYD) movement in the workplace has proven to be extremely beneficial for the healthcare industry, allowing providers to access patient data, billing information, clinical trial data, and employees information on the go. Okay. Some challenges, okay, with bring your own devices. Okay. No clear usage policies, large mobile devices, failure to set password, internal external data breach, recovery of lost data, reactive security posture, defense in depth, no clear corporate chain of responsibilities, and change. So prior to permitting staff's use of their personal device in clinical area, it is important to establish a policy to ensure that protected health information (PHI) is safe, and that the institution can wipe devices clean if it's compromised, and that the passwords are required to access the devices. Okay. Now let's see the next component in health medical devices. Okay. Medical devices are essential for safe and effective prevention, diagnosis, treatment, and rehabilitation of illness and disease. Okay. In this picture, we can see types of medical devices. Okay, like patient monitor, vital signs, fetal monitor, lipid analyzer. Okay. Data integration and use of interface engine are essential in healthcare IT. Interface engine permits system to be connected correctly. It is not enough to simply send data from one application to another. There are many rules that may be followed. Okay. Arrow line. Arrow line shows how data can be exchanged between medical devices and EMR system using medical device integration system. This line shows, okay, how Okay. CEN, ISO and IEEE 11073 standards enable communication between medical devices, healthcare and wellness devices with external computer system. Okay, remember this is for exam point of view, it's very important. Okay, medical device integration we'll see. Okay, medical device integration solution is a software-based vendor-neutral solution that automatically collects and integrates patient vital sign data generated from various medical devices to electronic medical record system wirelessly or wired. Okay. The solution deploy and middleware to communicate with EHR using HL messaging centrally. Okay, HL7. Okay. Health level 7. HL7 refer to a set of international standard for transfer of clinical and administrative data between software applications used by various healthcare providers. Okay, leading healthcare data interchange standards. Clinical system use HL7, retail pharmacy order and reimbursement use NC-PDP, waveform use HL7 standard, image and pictures use DICOM, bed instrument use IEEE MIB ASTM. Okay. Adverse event reporting use HL7, provider repository use HL7 and X12N. Agency reporting they use also HL7 and X12N. Immunization database they use HL7. Billing claim and reimbursement use HL7 and X12N, non-US only. Okay. Remember this point. CN ISO IEEE 11073 Health Informatics Medical Health Devices Communication Standard enable communication between medical, healthcare and wellness devices with external computer system. Okay. Now we'll explore the applications part. Next component, applications. Okay. The application used by administrative, clinical and support staff to process and store data, manage patient record and provide information. Applications can be one vendor application. Everything is provided or developed by one vendor. Okay, one vendor. Okay, best of breed applications, like every department get what is the best application available in the market and they apply in their department, and commercially off the shelf. Okay, and in-house develop. Now to explore networks. Okay, the wired or wireless connection that link the infrastructure together and enable accessibility of application and patient data. Okay, networks. We will now see the types of networks, network topology and communication protocol. We will see the types of network. Okay, network can be local area network. Okay, local area network, wide area network, wireless local area network, metropolitan area network, storage SAN, storage area network. SAN can be storage area network, system attached network, server area network, or sometimes also known as small area network. Now let's see network topology. Network topology is the schematic description of network arrangement connecting various nodes, sender and receiver through lines of connections. Okay, this is star topology, mesh topology, ring, bus. Okay, fully connected tree and line. Now we'll see the communication protocol. A communication protocol is a system of rules that allow two or more entities of a communication system to transmit information via any kind of variation of a physical quantity. Okay, communication protocol. Okay, protocol rules that ensure communication among different types of computer from multiple manufacturer. Okay, open system interconnections, leading protocol model, compromise of 7 layers, transmission control protocol, internet protocol, TCP/IP, two communication protocol of internet that work together rapidly overtaking OSI. And there is a system network architecture, IBM's proprietary communication protocol, and Ethernet protocol, a standard developed for local area networks using a bus topology, and X.400 and X.500 standard for message handling and network directories. The OSI open system interconnection, 7 layers and network model, and TCP/IP. See, okay. Under TCP/IP model, there are how many layers? 4 layers: application layer, transport layer, internet layer, and network access layer. Okay. And under OSI models, there are 7 layers. It have a physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and applications layer. To make it easier to memorize this, remember this: PDNT dash SPA. P stand for physical, D stand for data, N stand for network, T stand for transport, S stand for session, and P stand for presentation, and A stand for application. For TCP/IP model, remember ATIN: A for application layer, T for transport, I for internet, and N for network access layer. Okay. Remember this: FTP and STTP and Telnet protocol work on this application layer. JPEG and MPEG, all the conversion protocol, work at presentation layer. Okay. And so at physical layer, Ethernet and Wi-Fi, all the physical like wire connections take place here. Let us try to understand with one more picture. Okay, let's see. At application layer, okay, DNS, WW, STTP, P2P, email, POP, SMTP, Telnet, all this work at applications layer. At presentation layer, recognizing data like HTML, doc, JPEG, MP3, AVI work at presentation layer. At session layer, session establishment in TCP, SIP, RTP, RPC. Okay. A transport layer means end-to-end connection and reliability. TCP, UDP, HTTP, SSL, and TLS work at this layer, transport layer. And network layer, path determination and logical addressing, IP, ARP, address resolution protocol, IPsec, okay, ICMP, IGMP, and OSPF or work at network layer. And data link layer, physical addressing take place at data link layer, and all this work like Ethernet, 802.11, MAC, LLC, VLAN, ATM, SDP, fiber channel, frame relay, SDLC, PPP, all tokening, all this work at data link layer. At physical layer, media signaling and binary transmission, RJ40, okay, RS-232, RJ45, 100 base TX, all DSL, okay, 802.11, all this work at physical layer. Now let's explore third topic: trends and challenges in healthcare technologies. Under this, we will study healthcare information action, interoperability standards, data integration, data warehouses, telehealth and telemedicine, and privacy and security. Let's explore Health Information Exchange. Health Information Exchange allows doctors, nurses, pharmacists, other healthcare providers and patients to appropriately access securely share a patient vital medical information electronically, improving the speed, quality, safety and cost of patient care. Okay. So, Regional Health Information Exchange. Health information organization that bring together healthcare stakeholders within a defined geographic area and governance health information exchange among them for purpose of improving health care in that community. I will read it again. Health information organization that bring together with healthcare stakeholders within defined geographic area and governance health information exchange among them for the purpose of improving healthcare in that community. Now we'll see health information exchange. HIE is defined as the mobilization of healthcare information electronically across organization within region or community. Health information exchange provides the capability to electronically move healthcare information between various systems while maintaining the meaning of the information being exchanged. In other words, it is the set of technologies that bring all the personal health information required to make safer, more informed decision at the point of care. Now see NIHN, Nationwide Health Information Network. Okay. Nationwide Health Information Network is a set of standards, services and policies that enable secure health information exchange over the internet. The network will provide foundation for exchange of health information across diverse entities within communities and across the country, helping to achieve the goal of HITECH Act. What is HITECH Act? Health Information Technology for Economic and Clinical Health, also called HITECH Act, enacted as a part of the American Recovery and Reinvestment Act of 2009, was signed into law on February 17, 2009 to promote the adoption and meaningful use of health information technology. Now see interoperability and standards. Okay. Interoperability is the ability of two or more systems or components to exchange information and to use the information that has been exchanged. To support interoperability between systems and meaningful sharing of data, health information standard must cover both the syntax, structure, and semantic meaning of the data exchange. Interoperability standards are not software or hardware, but the blueprint that technology developer can use to develop health information system that will be inherently compatible with other systems adhering to this same standard. Okay, interoperability standards. A standard for health interoperability exists to allow health information system to communicate with the same way across system, organizational, regional, and national boundaries. Okay. So let's see what is messaging standard. Messaging standard outlines the structure, content, and data requirement of electronic messages to enable the effective, accurate sharing of information. The term message refers to a unit of information that is sent from one system to another, such as between a laboratory information system and GP's clinical information system. Okay, now see the terminology standards. Terminology standard provide a specific code for terminology and classification for clinical concepts such as disease and medications. Terminology system assign a unique code or value to a specific disease or entity. Document standards. Document standard indicate the types of information including document and also the location of information. Messaging standard. Now we'll see the example of each of one. Messaging standards. Example of messaging standard include HL7 V2.X for administrative data and digital imaging and communication in medicine, DICOM for radiology image. Okay. Example of terminology standard include ICD-10-AM, SNOMED, SNOMED, CT for clinical terms, and LOINC for laboratory result. And document standard. Example of document standards include the paper-based subjective objective assessment plan (SOAP) standard, and also HL7 clinical document architecture (CDA) for electronic sharing of clinical document. HL7 have developed document standard specification for continuity of care document HL7 CCD and discharge summary HL7 DS. Okay. Now see the data integration. Data integration and use of interface engines are essential in health IT. Interface engine permits system to be connected correctly. This image shows how data is exchanged among various healthcare applications using interface engine and HL7 messaging standards. Let's explore next topic, data warehouse. Data warehouse. Okay. Data warehouse is a collection of corporate information and data derived from operational system and external data warehouse. A data warehouse is designed to support business decision by allowing data consolidation, analysis, and reporting at different aggregate level. Data is populated into data warehouse through a process of extraction, transformation, and loading, also known as ETL. Okay. This image shows how data is transferred to data warehouse using ETL. ETL stands for extraction, transformation, and loading. This is ETL. Okay. And how OLAP, online analytical processing. This is OLAP, stands for online analytical processing. Okay. And how OLAP tool is used to generate report and statistic. Okay. Here reports are being generated through using OLAP tools. Also known as data mining tools. Okay. OLAP stands for online analytical processing tools. Make use of simple query to extract data from data warehouse via OPL, OLAP server, online analytical processing. Okay. ETL, extracting, transforming, and loading. ETL is the process of extracting, loading, and transforming data into meaningful form. It's happening through this. All reports are being created using ETL tools. Data mining is the process of sorting through large data set to identify pattern and establish relationship to solve problem through data analysis. Data mining tools allow enterprise to predict future trend. Okay. Let's see OLAP. OLAP support online report after performing certain joint operations and creating some cubes. OLAP consists of various applications for score, grading, reporting, dashboard, consolidation, planning, analysis, master data management, workshop, and foundations. Okay. An OLAP cube is multi-dimensional database that is optimized for data warehouse and online analytical processing application. An OLAP cube is method of storing data in a multi-dimensional form, generally for reporting purpose. In OLAP cube, data measures are categorized by dimension. This is a 3-dimension database. Okay. OLAP cube provides users the ability to create relationship and multidimensional views of different data sources. Can perform functions such as slicing, dicing, pivoting, rolling up, and drilling down. Okay. Now let's see the next topic. Telehealth and telemedicine. Telehealth is the use of electronic information and telecommunication technology to support long-distance clinical healthcare. patient and professional health related education, public health and health administration. Technologies include video conferencing on secure private network with store and forward imaging, streaming media and wireless communications. Telemedicine, the use of medical information exchange from one site to another via electronic communication to improve a patient's clinical health status. Telemedicine include growing variety of applications and services using two-way video email, smartphone, wireless tools, and other form of telecommunication technology. May involve medical scopes, X-rays, ultrasound, or other medical applications. Okay. Remember, telemedicine, the dynamic real-time remote interaction of healthcare professionals with individuals seeking health services. And telehealth, the passive capture of biometric and digital health information for self-monitoring and self-managing health and care needs to enhance well-being of the individual. And telecare, the management of health using a virtual collaborative approach of individualized direct and indirect interaction among protocols to proactively manage and deliver care with use of evolving technologies. And now see the next next technologies, emerging technology, privacy and security. Maintaining patient information, ensuring that it's kept private and secure is the first charge of EHR administration. Okay, Office of National Coordinator, ONC, provides resources to help you succeed in your privacy and security responsibilities. Okay, the U.S. Department of Health and Human Services, HHS, via Office of National Coordinator, ONC, okay, for Medicare and Medicaid services, CMS, and the Office for Civil Rights, OCR, support privacy and security through a variety of activities. This activity include the meaningful use of certified EHR, the Medicare and Medicaid EHR incentive program, enforcement of HIPAA rules, and the release of educational resources and tools to help providers and hospitals mitigate privacy and security risks in their practice. Okay, go to this link and study Guide to Privacy and Security of Electronic Health. This concludes my second video on the technology environment. I hope you find information presented in this video helpful in preparation of your exam. In the next video, I will cover the system analysis part. I would appreciate hearing your thought on this video. Please feel free to relay your comments, suggestion, or correction. Thanks for watching my video.